Good morning, students. Today we will discuss chapter 8 motion. We have already discussed some concepts in this chapter. Still, I will do the revision of earlier done concepts and we will also cover rest of the topics. Okay, let's move. Chapter 8 motion. An object in the universe can only be in either of the two states. Either it will be in the state of rest or it will be in the state of motion. State of rest means if the position of the object does not change with respect to the time, then it is said to be in the state of rest, or the state of motion when the position of the object changes with respect to time, then it is said to be in the state of motion. Describing motion is the change in the position of a body with time. Motion can be described in terms of distance moved or the displacement. Distance moved is the actual path length traveled by the body. Displacement is the length of the shortest path traveled by a body from its initial position to its final position. Example, if the body starts moving in a straight line from origin O and moves through C and B and reaches to A, then moves back and reaches to C through B, then the distance traveled will be, total path will be 60 plus 35, it will be 90, and displacement will be 25 kilometer because it is the shortest path between final and the initial position. Uniform, non-uniform motion. If a body travels equal distance in equal interval of time, then it is said to be uniform motion, and if it covers unequal distance in equal interval of time is said to be in non-uniform motion. Speed of a body is the distance traveled by the body in unit time. Speed formula is distance upon time. V is equal to S by T. Its SI unit is meter per second. Since it has only magnitude, it is a scalar quantity. Average speed is the ratio of total distance traveled to the total time taken. Okay, let's move. Speed with direction. When we discuss or consider the direction with speed, then it is said to be velocity. Okay, velocity of a body is the displacement of body per unit time. Displacement upon time taken is equal to velocity. Since it has both magnitude and direction, it is a vector quantity. Average velocity is the ratio of total displacement to the total time taken. Average velocity is also the mean of initial velocity u and final velocity v. Average velocity is equal to initial velocity plus final velocity divided by 2. V average is equal to u plus v by 2. Okay, and its unit will remain same as it is meter per second. Rate of change of velocity. Whenever we will discuss about the rate, that means the change with respect to time. Okay, the change in velocity of a body per unit time is called acceleration. If the velocity of a body changes from initial velocity u to final velocity v, then the acceleration will be equal to a is equal to v minus u by t. It is SI unit is meter per second square. Uniform acceleration, if the change in velocity in equal interval of time is uniform, then it is called uniform acceleration. Non-uniform, if the change in the velocity is unequal in equal interval of time, it is said to be non-uniform acceleration. Graphical representation of the motion. There you can see the distance time graph. Two types of graph we will study over here. Uniform distance time graph for uniform motion. Okay, let's see. You can see in the along the x-axis the time is taken, along y-axis distance is taken, and you can see in every interval of time equal amount of distance is covered. Okay, so 0 to 5 seconds 10 meter, and again 5 to 10 it is 10 to 20, again it is 10 meter. So equal amount of distance is covered in equal interval of time. Non-uniform speed, you can see over there the time taken, the quantity which changes in equal interval is taken along x-axis, and the quantity which changes along in unequal interval is taken along y-axis. You can see over there the distance traveled in 0 to 5 seconds is lesser in comparison to the distance traveled in 15 to 20 seconds. So that you can see the shape of the graph also. It is not a uniform, it is a curved graph. Okay, so my graph for distance time graph for body moving with non-uniform speed. Okay, let's move. Velocity time graph for body with uniform motion. You can see if an object is moving with the speed of 20 km per hour in every or equal in each interval of time, then it is said to be the velocity time graph for uniform motion. Okay, at any time whenever you will try to measure or try to see the speed is equal, it is 20 kilometer per hour. Okay, velocity time graph for uniform acceleration, you can see over there also. Okay, in every interval of time the change in the velocity is equal. Okay, so that's why it is called velocity time graph for uniform acceleration, deaccelerated motion or negative acceleration you can call it. And second is for non-uniform, and sometime you can see the curve is increasing, sometime it is decreasing, again it is increasing, and finally it is decreasing for non-uniform motion. Okay, acceleration can be of three types: positive, zero, and negative also. Now the important topic, most important topic of this chapter, it is most important topic of this chapter, equation of motion by graphical method. Dear students, this is the most important topic of this chapter. Usually came in exam for either 3 marks or 5 marks. If in 5 marks, then all three equations will be there, and in 3 marks any of the equation can be over there for the derivation. The motion of a body moving with uniform acceleration can be described with the help of three equations called the equation of motions. You all know the first equation is V is equal to U plus AT, S is equal to UT plus half AT square. Third equation is 2AS is equal to V square minus U square, where the symbols have their usual meanings. U initial velocity, V final velocity, A acceleration, T is the time, S is the distance. Okay, let's move further. Try to understand these equations. First equation, it is equation for velocity time graph. V is equal to U plus AT. Draw the graph properly. Okay, there mark all the points. A initial velocity, A at point A it is initial velocity U, at point E it is final velocity V, AB is the slope, it will give us the acceleration. Okay, now join all the lines. O to C is the time interval which will be equal to AD. OC is equal to AD is equal to T. AO is equal to OC is equal to U. OE is equal to BC is equal to V. Okay, BD will be equal to BC minus DC, it will be, it is equal to V minus U. Okay, let's see, you can observe this. Acceleration is equal to change in velocity. Change in velocity, acceleration can be also find out with the slope of this graph. AB is equal to BD upon AD, or BD upon OC you can consider. It is equal to V minus U upon V minus U. BD we already discussed, it is BC minus DC. v minus u by t, and multiply t on other side, it is equal to v minus u is equal to at, or v is equal to u plus at will give us our first equation of motion for velocity time relation. Okay, let's move further for the derivation of second equation. See this equation of motion, we will use the same graph, same will be the parameters, and in this particular equation we will find out the distance position time relation. It is position s is equal to ut plus half at square. S is will be the distance covered by the body between point A and B, is the area of OAC, OABC, okay, trapezium it is, and S is equal to area OABC, which is a trapezium, and it will be equal to area of triangle ABD plus area of rectangle. First we will consider area of rectangle. As you all know, length into breadth, OA into OC, plus half perpendicular, half base into perpendicular. Okay, see this, use all the values for them, put all the values in equation, then s is equal to u into t plus half into t into at, which is equal to s is equal to ut plus half at square. Okay, it is very much easy. You need to find out the area of the trapezium, which is equal to s is area of rectangle plus area of triangle. Okay, then use a basic formula for rectangle as well as for area of triangle, half into base into height it is. Okay, put all the values and then you will easily find out the, you can easily find out, you can easily find out the second equation, that is position time relation. Let's move further. Third equation, that is position velocity relation, it will be equal to v square minus u square is equal to 2as. We will use the same graph, and also we will consider the distance traveled by the body between point A and B is equal to area of trapezium. Again we will consider over here, it will be equal to 1 by 2 sum of the two parallel sides into the distance between two parallel sides. Okay, it is equal to, substitute the values for them, sum of two parallel sides, it is OA plus BC into distance OC, or OD we can use, AD we can use, sorry, substitute these values with them. Then from velocity time relation, use the value of t from first equation and put this value into s is equal to u plus v into t, it is equal to v plus t is equal to v minus u by a. Okay, then s is equal to, substitute all the values, v plus u into v minus u upon 2 it is, and cross multiply this, 2as is equal to v minus u square. Okay, this is our third equation of motion. Dear students, keep in your mind these equations will be used lifelong till you will study science. Okay, these equations are of very much great importance, so derive these equations, all three equations, at your home. And now we will move to our next topic, that is circular motion. The motion of a body in a circular path is called circular motion. Uniform circular motion, if body moves in a circular path with uniform speed, then its motion is said to be uniform circular motion. Uniform circular motion is accelerated motion, because in a circular motion a body continuously changes its direction. The circumference of the circle of radius r is given by 2 pi r. Okay, if the body takes time t to go once round in a circular path, then its velocity v is equal to 2 pi r by t. Okay, you can understand in other way also. You consider a straight line, then join two lines, then make it a triangle, then make it a rectangle, then make it a pentagon, then make it a hexagon and make it a octagon. What it means, what we are doing, we are increasing the number of sides, we are increasing the number of sides, and at the same time what we are seeing, every time with the increase in the number of sides, the direction of motion is also changing. So in a circular motion, the position, direction of the object will change at every instant. Okay, so dear students, tomorrow we will study about the exercise questions and the questions in text of the chapter, and then try to solve them. We will try to solve them. Okay, thank you so much. Have a good day. Enjoy your day. Okay, if any query, you can straightforward ask without any hesitations, and your suggestions are always welcome. Thank you. Thank you so much. Enjoy your day. Good day. Okay.